Hello and welcome to this session. In this session, we are going to discuss the following question, and the question says that find the solution of the given system of equations using Gaussian elimination method. Minus x plus 5y minus 3z is equal to 4. 3x plus 5y minus z is equal to 3. And x plus y plus z is equal to 2. The Gaussian elimination method involves the following steps. First, write the augmented matrix of the given system of equations. Second, reduce the augmented matrix to row echelon form using elementary row operations. Third, rewrite the reduced augmented matrix into the system of equations. And lastly, solve the obtained system of equations using back substitution. Now with this key idea, we shall proceed with the solution. We are given the following system of equations: minus x plus 5y minus 3z equal to 4, 3x plus 5y minus z equal to 3, and x plus y plus z equal to 2. First we write its augmented matrix. The first three columns are of the coefficient matrix, that is minus 1, 5, minus 3, 3, 5, minus 1, 1, 1, 1. And the last column is of constant matrix, that is 4, 3, and 2. Now we reduce it into row echelon form using elementary row operations. For this, we have to make all entries below the first non-zero entry in that column 0 and the leading entry should be 1. We start with the first row. Here, leading entry is minus 1. We multiply row 1 by minus 1 to get rid of the negative sign. So we have the matrix 1, minus 5, 3, minus 4, second row 3, 5, minus 1, 3, and the third row has elements 1, 1, 1 and 2. So here the elementary row operation that was used was R1 goes to minus 1 into R1. Now we have to make all entries below 1 in the first column equal to 0. In the second row, we have 3 below 1 and we have to make it 0. For this, we multiply the first row entries by 3 and subtract it from the entries of the second row. So we have the row operation R2 goes to R2 minus 3 R1, and our second row now becomes 0, 20, minus 10 and 15. Also in the third row, we have 1 in column 1. We have to make it 0. For this, we subtract row 1 from row 3 and we have the operation R3 goes to R3 minus R1, and the last row of this matrix now becomes 0, 6, minus 2 and 6. Now we come to the second row. We have large terms, so to simplify this we multiply row 2 by 1 by 5. As 5 is common in all the entries of row 2. Also in row 3, 2 is common in all entries, so we multiply row 3 by 1 by 2. And hence we obtain the matrix where the first row entries are 1, minus 5, 3 and minus 4. The second row entries are 0, 4, minus 2, 3. The third row entries are 0, 3, minus 1, 3. Now for row 2, we choose the following operation. We subtract row 3 from row 2. So our matrix becomes, the first row entries are 1, minus 5, 3 and minus 4. The second row entries now become 0, 1, minus 1, 0, and the third row entries are 0, 3, minus 1, 3. Now we have to make the entry below the leading entry of row 2 0. We have here 3. Now we multiply row 2 by 3 and subtract it from row 3. So the elementary row operation is R3 goes to R3 minus 3 R2, and the matrix obtained is 1, minus 5, 3 and minus 4 in the first row, 0, 1, minus 1 and 0 in the second row, 0, 0, 2 and 3 in the third row. Now in the third row, we have to make the leading entry 1 instead of 2. So we multiply row 3 by 1 by 2 and we have the matrix 1, minus 5, 3 and minus 4 in the first row, 0, 1, minus 1, 0 in the second row, and 0, 0, 1 and 3 by 2 in the third row. This matrix is now in row echelon form. Now we write its equivalent system of equations for this reduced augmented matrix. We have x minus 5y plus 3z equal to minus 4, y minus z equal to 0 and z equal to 3 by 2. Now we solve this system of equations using back substitution. We have z equal to 3 by 2. Put this value in y minus z equal to 0. We get y minus 3 by 2 equal to 0, which implies y is equal to 3 by 2. Now put y equal to 3 by 2 and z equal to 3 by 2 in x minus 5y plus 3z equal to minus 4. We get x minus 5 into 3 by 2 plus 3 into 3 by 2 is equal to minus 4, which implies x minus 15 by 2 plus 9 by 2 is equal to minus 4, which implies x minus 6 by 2 is equal to minus 4, which implies x minus 3 is equal to minus 4, that is x is equal to minus 4 plus 3, which is equal to minus 1. So the solution is x equal to minus 1, y equal to 3 by 2 and z equal to 3 by 2. This is the required answer. This completes our session. Hope you enjoyed this session.